Okay, so in class, we talked about what polar coordinates are and why it would be useful to sometimes use polar coordinates. And we ended with talking about how A, G, and H here are all in the same spot. That 3 pi over 3, 1, 2, 3, pi over 3, negative 3, 1, 2, 3, and then 4 pi over 3, 2, 3, 4 pi's over 3, and positive 3, 7 pi over 3 are all in the same place. So that the point here is that there are lots of different ways to travel in polar coordinates to the same spot. There are infinitely many representations of the same point. And so that can make things kind of confusing. And we'll see a little bit of that come up in section 6.4. Now, what we want to talk about is this picture should look familiar to you. This is kind of the picture we've been looking at since day 3 of pre-calculus, where we have this right triangle in the first quadrant, and theta is this angle, x and y are the sides of the triangle, and then r is the hypotenuse / the radius. So we are looking at that cosine of theta is equal to x over r, but if we would like to have x's and y's on one side and r's and thetas on one side of the equation, we're going to multiply both sides by r to get r cosine theta equals x. And then similarly, sine of theta is opposite over hypotenuse, so you're looking at y over r. Multiply both sides by r, you get r sine theta equals y. Now, for something between theta, x, and y, you're looking at tangent. Tangent of theta is opposite over hypotenuse, so you have tangent of theta is y over x. And lastly, the Pythagorean theorem that the two legs squared and added together is the hypotenuse squared. So x squared plus y squared equals r squared. Okay, so the first thing that we're going to do, we're going to convert from one representation to the other. So I want to mention that these two most often we will use when we know what r and theta are to find x or to find y. And these two we will often use when we know x and y so that we can find theta and so that we can find r. So for number 4, we have that r theta is 2 pi over 3 and xy is 1 root 3. And so either way, these should be in the same spot. 2 pi over 3 is going to be here-ish. And this is at least in the first quadrant, that 1 root 3 ordered pair, because they're both positive. So we know that that's in the first quadrant also. Let's see that they are the same point by using those top two equations up here. So we have x equals r cosine theta. R is 2, cosine is pi, theta is pi over 3. So you're looking at x equals 2 cosine pi over 3. So this is 2 times the cosine of pi over 3, which is a half, and then that is 1. And so the x value is 1, which we were given. And then you also have y equals r sine theta. So you're going to do the same thing here. So 2 times the sine of pi over 3. The sine of pi over 3 is root 3 over 2. Those 2's are going to cancel and you have root 3 for y, which is what we were given. So those are the same point. They're in the same spot. It's just different representations of the same point. One in polar and one in rectangular coordinates. All right, for number 5a, I'm just going to draw a picture and then B will work this out. So for 5a, we are going to look at, this is in polar coordinates, so this is r and theta. So we're going to count out 1, 2, 3, and then rotate around pi. If I think about this in rectangular coordinates, that's just -3, 0. And you could do the x equals r cosine theta stuff to confirm that. Let's do that over here. -10 pi over 6 is going to be somewhere down here in the third quadrant because you're going to count -10 and then rotate 30 degrees. So we have x equals r cosine theta. So that would be -10 times the cosine of pi over 6. That is -10 times root 3 over 2. So that is -5 root 3. And then similarly, you're going to use the y equals r sine theta formula. So -10 times the sine of pi over 6. well, the sine of pi over 6 is a half, so you're looking at -5. So in rectangular coordinates, that ordered pair is -5 √3, -5. Okay, now converting from rectangular to polar, we have some options here, and so these are a little bit trickier. Let's do number 6 first. We're always going to sketch these things to help us. So the xy ordered pair is -1, 1, so that would be here. And then we're going to use those formulas. So x squared plus y squared is r squared. And that tangent of theta equals y over x. So this is -1 squared plus 1 squared is r squared. That's 2 is r squared, which means the r is plus or minus √2, which is good. Those are the two things we have. And then next we're looking at the tangent of theta is y over x. And so we're looking at -1 over 1. So the tangent of theta is -1. And if you do tan inverse, or think about where is tangent equal to -1, that happens at 3 pi over 4. Or 3 pi over 4 or 7 pi over 4. And so looking at this, if we're going to go back to our picture now, and we're going to choose a positive square root of 2 radius. So how far, which pi over 4 would I choose to get to here? You would choose 3 pi over 4. So √2, 3 pi over 4 is that, is an ordered pair that would work. You could also do -√2 and 7 pi over 4. Or you could do -√2 and pi over 4. So you're rotating clockwise, which would be a negative angle. So that would also work. You could do a positive √2 as well with a negative angle. This would be 5 pi over 4. That's just another option. √2 and 5 pi over 4. Okay, so on this one, converting from rectangular to polar, if I'm looking at +1, then -√3, that would be down here in quadrant 4 somewhere. This is an xy ordered pair. So x squared plus y squared equals r squared. That would be 1 plus 3 equals r squared. That's 4 equals r squared, so r is plus or minus 2. And then tangent of theta is y over x. So theta is going to be tan inverse of that. So I'm thinking, where is tangent equal to √3 over 1? That would be where sine is √3 over 2. So that happens at a pi over 3. And this would be -pi over 3. So an ordered pair that works here would be +2, pi over 3. And that's in the right spot. You would go +2 and then rotate down to -pi over 3. Now you could come up with some other representations like we did up here, but you do not have to. On your exam, I will probably tell you what restrictions I want for r and for theta, and so you'll know how to do this. On B, we don't actually need to do any work. This is our xy ordered pair. If x is 0 and y is -4, we're sitting down here. So that in for a radius and an angle, the radius is 4 and the angle is 3 pi over 2. Or you could do -4 pi over 2, that would work as well. Go -4 and then rotate 90 degrees, or go +4 and rotate 270 degrees. Okay, so like I mentioned above, when we know r and theta, we're going to plug them in here to solve for x and y. When we know x and y, we're going to plug them in here to solve for r and for theta. Okay, so why are polar coordinates helpful? This happens with, well, here's a place where they're not. Thinking about this 2x minus 1, this y equals 2x minus 1, you would go here, and then your slope is 2, so 2 over 1. Okay, so here's your line. And like, that's not that hard to do. But if we put this in polar, this would be that r sine theta, because that's y, equals 2 times r cosine theta, because that's x minus 1. If you hit the polar button in your calculator, instead of having y equals when you go to graph like y1, y2, whatever, instead of that, if you're in polar mode, it's going to be r1 equals, r2 equals. So we, in theory, want to solve this for r. So you would move those to the same side. So r sine theta minus 2r cosine theta equals -1. And then you're going to pull out that r. And then you're going to divide by this. So you're looking at r then is equal to -1 over sine theta minus 2 cosine theta. So that's not particularly helpful to use polar coordinates for that, but it's really helpful for circles. If we were talking about the unit circle in particular, x squared plus y squared equals 1. If you wanted to graph this in your calculator, you would have to graph this as y equals the square root of 1 minus x squared. Then y1, and then y2, you would have to graph negative square root of 1 minus x squared. So you get this top half with that first one and the bottom half with the second. If you're in polar, all you have to do is graph r equals 1. Like, this is better. And so that is when the polar coordinates are helpful. Theta equals pi over 3. It's going to look like this because we don't know what the radius is. That's what theta equals pi over 3 would look like in rectangular. Tangent of theta equals y over x. Let's use that. So we have tangent of pi over 3, which is root 3 equals y over x. So root 3 times x equals y. So it's a slope. It's a line with slope root 3 and y-intercept of 0. And this is what it looks like. Okay. Converting sum to rectangular, converting equations, you're just basically looking for the substitution. So r sine theta is y. So you're looking at y minus 2 equals 4. So y equals 6. Sometimes it's harder to do, like on this one, I can't just get rid of that cosine. If I want to change this into rectangular coordinates, I'm going to have to multiply both sides by r. And that's going to allow me to change r squared to x squared plus y squared. And it's going to allow me to change r cosine theta to x. This comes from those 4 equations, these 4 equations, using them in the most beneficial way. Okay, I'm going to skip number 13. What I would like for you guys to do before Monday is number 1 here, number 2. I'm actually going to walk you through one of these. Watch the video for this one, the example video. It'll help you with that one. These are like what I did just now. And then you're going to save these for me on Monday. We'll do 5 and 6 together on Monday. But I would like for you guys to do 1 through 4. Let me do one of number 2 right now. So if we have the point 6, 7 pi over 6, that would be down here. So this is 6, 7 pi over 6. I would like another ordered pair that's still in polar coordinates, where r is negative and theta is between 2 pi and 4 pi. So if I use r negative, r would have to be -6. So r is going to be -6. And then what would a positive angle be that gets me to here? Well, it's just 1 pi over 6. So you can use -6, 1 pi over 6. But if I would like for this angle to be between 2 pi and 4 pi, I need to go around again. So I'm going to go to here, and then I'm going to go all the way around again. So that's going to be 13 pi over 6. And then on B, we want R to be positive. Okay, well, that means R has to be 6, and we want theta to be negative. So if we choose a positive radius, I want theta to be negative. That means I need to go this way. So that would be negative 5 pi over 6. Okay, so what you're going to do is plot these A through E, work through 3 and 4, and then we will talk about the rest of these. You can try them, but we'll talk about the rest of them on Monday before we get into 6.4 stuff. All right, thank you so much.